All right, hey guys. I just wanted to show you that video. That was a Nike basketball commercial that came out sometime when I was in high school. I don't know exactly when, but I just love that commercial. It's so cool. It's got all these great old players in it. It's got Baron Davis. He makes a cameo. Darius Miles, White Chocolate himself, Jason Williams. Go look up Jason Williams. He's hilarious. I think KG's in there for a little bit. Rashid is in there for like 4 seconds. It's such a great commercial, and oh god, those moves are so awesome. But I remember scouring the internet when I was younger to try and find it online. But anyways, let's go ahead and take a look. We're starting off section 7.4. Happy Romanian Independence Day to all of our Romanian friends out there. May 9th is a huge day for them. But what we're doing is binomial expansion. Okay, so we're not really going to be focusing on the Romanians. Sorry to all of our Romanian friends. Okay, now, before we talk about binomial expansion, okay, first we have to talk about this new concept called a factorial, or n factorial, okay? Now, this right here is n factorial. Now, it says n exclamation point. Now, you don't want to say n, or 5, or 7, okay? This is a factorial, okay? It's a specific operation. Sorry, I shouldn't have done that. And what that means is n factorial means you're going to multiply n by every whole number that comes before it all the way down to 1. So n times n minus 1 times n minus 2, all the way down n minus 3 times n minus 4, all the way down to 3 times 2 times 1. Okay? So, for example, 5 factorial is equal to 5 times 4, whoops, a little writing issue here, times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is itself. 7 factorial is going to be 7 times 6 times 5. Now, every number after 5, or after 6, I should say, is 5 times 4 times 3 times 2 times 1, which is the same as 5 factorial, which I've already just solved for. So what I can do instead is just multiply 7 and 6, 42, and 5 factorial I already know is 120, and this becomes 5,040. Okay, and now here's kind of a quirky property of factorials. 0 factorial is 1. I know that doesn't make any sense, okay? But you'll see why with this, what we're going to do in a little bit, why 0 factorial is called 1, okay? And now here's another example, 10 factorial divided by 8 factorial. Now, I'm not going to multiply all these numbers out, but I am going to write out what I would multiply. So 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And look what happens here, right? Since everything is just being multiplied, you can cancel out the 8 factorial from the numerator, right? Because 10 factorial is 10 times 9 times 8 factorial, with the 8 factorial in the denominator, so you're left with 10 times 9, which is 90. Okay, so those are factorials, okay? Whenever you see that exclamation point, right, you're going to multiply by every number that comes before it all the way down to 1. Okay, all right, so now we're going to move on to something else, okay? And this really is the precursor to binomial expansion, okay? Multiply out the following. Okay, x plus y in parentheses like this is a binomial, right? Hopefully we knew that, right? That is a binomial, okay? Now, x plus y to the first power is just going to equal x plus y. X plus y squared, well, you guys know how to FOIL this out, right? X plus y times x plus y is x squared plus 2xy plus y squared. X plus y cubed, I don't know if any of you guys ever memorized this, but right, this is x cubed plus 3x squared y plus 3y squared x plus y cubed. And now x plus y to the fourth, right, I could take my answer for x plus y cubed and multiply this by another x plus y, and what I would get is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth. Okay? And now we're going to be learning some tricks here that go along with expanding out these binomials. Okay? One of the tricks, and this is kind of neat, we're not going to use this a lot, but it is kind of a cool thing to know, is Pascal's triangle. And I wish I was there, I could ask you guys how many of you guys know this, but this is a really famous thing in mathematics. These patterns in this triangle come up a lot. Okay? And here's how it works. Okay? You know, think of it like a pyramid. You're working from the top downwards to the bottom. Okay? Now, along the left slant and along the right slant are all ones. Okay? Now, every number beneath two numbers is the sum of those two numbers, right? So that 2 in the middle right here is the sum of 1 plus 1 above it. The 3 is the sum of the 1 plus 2 above it, right? 4 is 1 plus 3. 6 is 3 plus 3, right? 4 is 3 plus 1, right? And so on and so on. Okay? And one thing you'll notice is that the numbers in the rows here line up with the coefficients we just got. Right? So when I did x plus y to the first, I got 1x plus 1y. Okay? And now this looks like the second row, but what we're going to do is we're going to actually call that the first row. Okay? And at the top here, we'll call that the 0 row. And that's because x plus y to the 0 power, anything to the 0 power is just 1. Okay? The second row gave us 1, 2, and 1. And if I look at x plus y squared, I get 1, 2, and I get a 1. Right? And so on and so forth. X plus y cubed, the coefficients are 1, 3, 3, and 1. Which is exactly what the third row is. And so on and so forth, right? X plus y to the fourth had these coefficients, right? 1, 4, 6, 4, and 1. Okay? So this is Pascal's triangle. This is one method, right, for expanding binomial expressions. Okay? Now, here's another method. Okay, so at the top of the next page, right, we have this concept of the binomial coefficient. And this is why we just talked about factorials a moment ago. Okay? NCR. Okay, so think of C as the coefficient. Okay? N and R here are two positive numbers. Okay? And now we'll talk about how this relates with the binomial stuff in a moment here. But here is a new operation. Okay? Whenever you see two numbers like this in parentheses, N over R, right? So not really over, it's not necessarily a fraction. Okay? Here's what you're going to do. You're going to do N factorial over R factorial times N minus R factorial. Okay? So let's try that with the two values I have here, right? I want to find 3 and 2 here. Okay? So the binomial coefficient here of 3 and 2 is going to be 3 factorial over 2 factorial times 3 minus 2 factorial. Now, these numbers are small enough where I can evaluate them, okay? But one thing I'm going to do here is I'm going to cancel some stuff out, right? 3 factorial is 3 times 2 times 1 over 2 factorial is 2 times 1. And now in the parentheses, 3 minus 2 is 1 factorial, which is just 1. And now 2's cancel, 1's cancel, and this becomes 3 over 1, which is just 3. Okay, let's try with some harder numbers. 5 and 3. I want the binomial coefficient here. This is 5 factorial over 3 factorial times 5 minus 3 factorial. So 5 factorial, now I'm going to leave this as 5 factorial for now, right? And this is going to be 3 factorial times 2 factorial in my denominator. And so this is going to be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. So 3's cancel, 2's cancel, 1's cancel, and now I have 5 times 4 over 2 times 1. 4 and the 2 will cancel, so I get 5 times 2, which is 10, over 1, which is just 10. Okay? Now, here's another neat thing here, okay? When r is 0, right, this is, right, r equals 0, or when r equals n, right, binomial coefficient 5 and 5 or of 5 and 0, right, I'm going to get the same thing because it's going to be 5 factorial over r factorial times n minus r factorial, which is, now if r is 0, you're going to get 5 factorial. If r equals n, these two would just be flipped the other way around. But it doesn't make a difference either way, right? Because 5 factorial over 5 factorial cancels out. And now this is why we say 0 factorial is 1. Because you have to have something in your denominator, right? 1 over 1 is just 1. Okay, now here's something that's kind of unique, okay, and the reason why we call this the binomial coefficient is because the answers we get here line up with elements inside Pascal's triangle, right? So when we did this first one here, okay, what we were really doing was we were looking at the third row of Pascal's triangle and we were looking at the second term. So let me go back to Pascal's triangle for a second. Third row, right? Second term is this 3 right there. Okay? And remember, right, the terms, the elements in Pascal's triangle also represent the coefficients when you expand these binomials, right? That's why this process is called the binomial coefficient. Right? Here's another one. We did 5 and 3. We're looking at the fifth term, fifth row, third term. So fifth row and third term, right? So here's the fifth row, and the third term was a 10, right? Which is exactly what we got when we did the binomial coefficient here of 5 and 3. Okay, fifth row, 0th term, or first term, I guess, either way. Well, oh, whoops. Okay, one tiner. Wow. I was going to say tiny or minor. I couldn't make up my mind. Sorry about that. Technically, the ones here are the 0th term, right? So when we were doing third row, second term, that was the 3 we were talking about. And this was the 10 we were talking about, right? Because when we did 5, 0, and 5, 5, right, we got 1 each time, right? So the 0 term and the 5th term of those rows, the 5th row, were both 1s. Okay? All right. So let's kind of put this all together, okay? And here's how we get the binomial theorem, okay? X plus y to an n here. Now n, right, has to be an integer. No, I'm sorry, let's say whole number. Let's say natural number. Let me make up my mind and get back to you. Okay, let n be a natural number. No, I guess it can be a whole number. Yeah, what are you talking about? This will still work, you moron. Yeah, let n be a whole number. So 0 is included. Okay? And now this looks really complicated, right? But this is actually the most effective way for expanding a binomial, right? Where you're up to some crazy exponent. Now, x plus y to the 4th isn't that bad, okay? Now this is going to be 4 equals n, okay? So the first term is x to the n. So here's x, right? So that's going to be x to the 4th. Plus, now let me find the binomial coefficient of n and 1. So 4 and 1 times x to the n minus 1, which is going to be 3, times y to the 1st, plus the binomial coefficient of n and 2, so 4 and 2, x to the n minus 2, which is just 2, times y squared. The next term, binomial coefficient of 4 and 3, x to the 1st, y cubed, plus, and now what I did right here, this was my second to last term, right? Binomial coefficient of n and n minus 1 is 4 and 3. So my last term is just y to the n, which is y to the 4th. Okay? Now, the binomial coefficient of 4 and 1, 4 and 2, 4 and 3. Okay? Now, we've already done these, right? We did this expansion earlier, so we know what this is going to come out to be. This is going to come out to be x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. Okay? Okay? And now, I want to point out a couple of things here, okay? So first of all, the coefficients still line up with Pascal's triangle, okay? This is going to be with the 4th row, all right? We're not really going to deal with Pascal's triangle, though, anymore. Just a neat little thing, all right? But one thing you'll notice, though, is that look at the degrees of your x terms. There's a 1 right there. And now this last term, I can technically think of, right, as being x to the 0. Right? The degree of x is going down by 1 each individual term, right? Now, compare this to the degree of y. So this first term I can think of as y to the 0, right? The next term is y to the 1st, y squared, y cubed, y to the 4th. The degree of y is going up by 1. Okay? Now, let's keep talking exponents for a second. Okay? What do you notice about the sum of your exponents? I know you can't respond. This makes this kind of awkward. But if you add your exponents together, right, the sum of the exponents is always equal to n. Okay? Now, this can change, right, depending on what you have inside your binomial. And you'll see some examples of this on your homework, you know. If my binomial was x to the fifth plus y to the fourth, you know, then obviously they wouldn't add up to n, right, because you'd be taking x to the fifth to the fourth power, then to the third power, okay? But when it's just x and y, your exponents are going to add up to n, okay? All right, let's try a hard one. Yeah. X plus y to the ninth. Woo. All right, here we go. N is going to equal 9. So this is going to be x to the ninth plus the binomial coefficient of 9 and 1. Degree of x goes down 1. Degree of y goes up 1. Next term, 9 and 2. X goes down 1. Y goes up 1. Next term, 9 and 3. X goes down 1. Y goes up. 9 and 4. X to the fifth. Y to the fourth. Plus 9 and 5. X to the fourth. Y to the fifth. Plus 9 and 6, x to the third, y to the sixth, plus 9 and 7, x squared, y to the seventh, plus 9 and 8, and I'm almost done here, x to the first, y to the eighth, and my last term is just going to be y to the ninth. Okay? Now, this looks like a lot of work. Okay? However, I assure you, it is much easier than foiling out 9 x plus y's. Okay? And if you want to do a speed race, we can definitely do a speed race. Okay? Now, I don't expect you to do all these binomial coefficients right now, but I know that you could, okay? So here's what we're going to do. I'm going to simplify this, right? This is going to be x to the ninth plus 9x to the eighth plus 36x to the seventh y squared plus 84 x to the sixth y cubed plus 126 x to the fifth y to the fourth plus 126 x to the fourth y to the fifth plus 84 x cubed y to the sixth plus 36 x to the second y to the seventh plus 9x y to the eighth plus y to the ninth. Whew. There's an answer right there. Okay, now this was a particularly long one. The ones on your homework aren't going to be this long, so you can feel free to walk away from the ledge. Okay, now one other thing I want to point out here. Okay, look at the exponent of y. Okay, the exponent of y is always equal, whoops, right? The exponent of y is always equal to whatever the second number in the binomial coefficient is. Okay, and now this last one I can write 9 and 9, right, to some, you know, okay. So that's just another thing to keep track of, okay. All right, let's do one last one here. A little easier, a little harder maybe, depending on your perspective, right? 4a minus 5b to the fifth. Okay, so no more x and y's here. We're going to big boy stuff, right? N equals 5, right? So now, the first term is 4a. That entire term is going to go to the fifth power. The next term is going to be 5 and 1 binomial coefficient times 4a to the fourth. Now, the entire second term is negative 5b to the first. Okay, so this term is going to come out negative. Okay, the third term is 5 and 2 times 4a cubed times negative 5b squared plus 5 and 3, 4a squared times negative 5b to the third power plus 5 and 4, 4a to the first times negative 5b to the fourth. And my last term plus negative 5b to the fifth. Okay? Now, you're going to have a scientific when you do these, okay? It's doable by hand. It's just, not really necessary, okay? Binomial coefficient of 5 and 1, all right? That one's going to be just 5, right? Times 4 to the fourth times negative 5. It's a little tedious, okay? So, use your scientific on these, right? And let's go ahead and simplify, okay? So 4a to the fifth. 4 to the fifth is 1,024. So that's going to be times a to the fifth. Now the second term is going to be negative because you have a negative 5 to the first power at the end. So negative 5 times 4 to the fourth times the binomial coefficient of 5 and 1, which is going to be just 5, by the way, is 6,400 a to the fourth times b to the first. Plus my next term, negative 5 squared is going to be a positive, so I don't have to worry about that, right? That's going to be 25 times 4 cubed times the binomial coefficient of 5 and 2, and this is going to be 16,000, excuse me, a cubed b squared. The next term is going to be a negative binomial coefficient of 5 and 3 times 4 squared, which is 16, times negative 5 cubed, and this is our biggest one, 20,000 a squared times b to the third, plus the next term, 12,500 a to the first, b to the fourth, minus 5 to the fifth, 3,125 b to the fifth. Okay? All right, and that's the binomial theorem. Okay? Identify the patterns. Okay, you identify the patterns, I think you'll be all right. All right? Okay, nicely done. Sorry I couldn't be there. I will see you guys mañana.